Welcome back, everyone. This is Mr. Cobalt, and we're going to start part two of the specific heat video. In the last video, we ended a little bit abruptly, and also I noticed that this was cut off a little bit. So just to recap, we solved our equation for Q, or I'm sorry, for delta T, and then we plugged in the values, negative 5,000 joules because it lost that amount of heat. So it's negative, and it's a 50 gram substance, and we have 6 joules per gram per degree Celsius for the specific heat. And when we calculated this out, we got negative 16.67 degrees Celsius. Okay, so let's go on to our last example problem, number 5. Okay, here we go with example problem number 5. Let me change this to 5. Okay, so we have a 25 gram piece of cold metal is put into hot water. Okay, so they're giving us the mass of the metal. So M is equal to 25 grams. And this cold metal is put into hot water. So we're expecting in this problem that you put a hot piece or you put a cold metal into hot water. Remember, heat is going to transfer from the hot to the cold, from a high concentration of where heat is to a lower concentration of where heat is less of. So from the hot to the cold. So here we're gonna expect that the metal, the cold metal, is going to absorb heat from the water, and that's what we're told. The metal absorbs 154 joules of energy from the hot water. So we've got our Q. So in this case, the metal, which is our system, is absorbing the energy, so that's going to be a positive value. So that's 154 joules. So a positive 154 joules of energy absorbed by the metal. The specific heat of the metal, oh, they're giving us that. So we got C is equal to 0.35 joules per gram degree Celsius. And what is the initial temperature? So they're asking us for the initial temperature. So T I is equal to what? Okay, so in this case, we have to know what the final temperature is, and so here in the problem, is of the metal if the final temperature is 25 degrees Celsius. So I forgot to add that part. Otherwise, we can't solve this equation. So they're giving us the final temperature. So T final is equal to 25 degrees Celsius. So in this case, we're going to have to write our equation with the TF minus the TI written out so we can solve for the initial temperature. So we're going to use Q is equal to the mass times the heat capacity, specific heat capacity, multiplied by T final minus T initial. Again, you can solve for the equation first and then plug your values in, or you can plug your values in first and then solve. This time I'm going to put my values in and then solve. So here I have the mass, so and I have Q. Q is plus 154 joules equal to the mass, which is 25 grams, multiplied by C, which is our heat capacity, so 0.35 joules per gram degrees Celsius. And then we have our final minus initial. So our final temperature is 25 degrees Celsius, 25 degrees Celsius minus the initial temperature. Oops. Let me rewrite this so it's more in the board. So we have, again, 154 joules is equal to the mass, which is 25 grams, multiplied by 0.35 joules per gram degrees Celsius. And then that is going to be final minus initial. So again, our final temperature is 25 degrees Celsius. So 25 degrees Celsius minus Ti. So in this case, we can multiply everything here. So if we do 25, hold on a second. So we can multiply these together, and then we'll get 875. So this is equal to 8.75. The grams are going to cancel out, so this is going to be joules over degrees Celsius multiplied by 25 degrees Celsius minus Ti, initial temperature, which is equal to 154. And then we can divide both sides, 154 joules. Then we can divide both sides by 8.75 joules per degree Celsius. 8.75 joules per degree Celsius. And in this case, the joules will cancel out. And then what we get there is going to be equal to, let me calculate this out really quick. Okay, and so we get an answer of 17.6. So here we have 17.6, and this is going to be 1 over degrees Celsius, and that's going to be equal to, oh, no, sorry, not 1 over degrees Celsius. This is going to be degrees Celsius is equal to 25 degrees Celsius minus the initial temperature. And so if I rearrange this, then I end up getting the initial temperature is going to be equal to 25 degrees Celsius minus 17.6 degrees Celsius. Oops, let me bring this down a little bit so we can see. So I get 25 minus 17.6, and so the final answer is going to be 7.4. So we get 7.4 degrees Celsius. So that is the initial temperature. So that is it for this video. If you enjoyed my videos, please, by all means, like, share the videos with your friends. Hit that like button right there. Hit that, smash that like button. Also, subscribe to my channel. Hit that notification bell. When you hit the notification bell, make sure you select all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think, and let me know if you got questions. I'd love to hear from you. Thanks for joining me. Have a great day.